Hello, Hornets, and welcome. Today I'm going to be going over the worksheet Continuity and Differentiability, worksheet number 1, and we're going over the last part of it, determining the values of a and b that make a function differentiable. Now, the first function that I have for us to work with is h of x equals, and we've got two parts, ax cubed minus 6x for x less than or equal to 1, and I have bx squared plus 4 for all x values greater than 1. Now there are two parts, continuity and smooth. Now the idea of continuity simply states that where one function starts, the other has to begin. So we're finding the value that's going to make them land at the same part or same point. So wherever this one lands, the other one has to start. That's the idea. Then we're going to be dealing with the idea of smooth. Smooth means that the derivative from the left and the derivative from the right are equal. This is that idea of the two-sided limit from the difference quotient as h approaches 0. So let's take a look at how we do it, all right? Here we go. We start by taking the two pieces and we set them equal to each other. Ax cubed minus 6x equals bx squared plus 4, and we're going to go at the change in domain 1. See, our domain changes 1 right there. This gives me a times 1 cubed minus 6 times 1 equals b times 1 squared plus 4, and I'm just going to simplify it until I can't simplify it anymore. I'm now going to move my a and b to the same side, and the constant's over. Now you'll notice the first issue that we have with the differentiability is because there are two variables, we need either two equations or we have to be given one of the variables on the offset. We don't have either. So this forces us to go to smooth. And we're going to take the derivative of this entire line. That means I have 3ax squared minus 6 equals 2bx plus the 0 for the 4. We're going to put in x equals 1 again. I get 3a minus 6 is 2b. For 3a minus 2b equals 6. Now at this point, you'll notice that we have the two equations that are going to be giving us the solution. So here we go. I'm going to write my system of equations in a way that I can do linear combination easily. Now, if you prefer to do substitution, you're going to want to find out what a or b equals from this equation right here, and then plug it into the second one and solve for the remaining variable. Once again, that's up to you. I'm going to go ahead and I'm going to get rid of my 2b. I'm currently going to multiply by negative 2 so that they are opposites and will cancel. 3a minus 2b equals 6. I end up with negative 2a plus 2b equals negative 20. Because the b's are opposite, they cancel, and I'm looking at a equals negative 14. I'm now going to do my substitution method. So I'm going to take this value. I prefer a minus b equals 10, and I'm going to substitute the a for negative 14. I'm now going to solve by adding 14 to both sides and then multiplying through by a negative in front of b. I end up getting b equals negative 24, and my a was negative 14. Alrighty, let's go ahead and take a look at the second problem from this portion of the worksheet. And we're looking at g of x, and g of x is equal to, we have 2x plus a, x is less than or equal to 1, and bx squared minus 1 for all x is greater than 1. We set them equal for the continuous. We're going to take the derivative for the smooth. Here we go. 2x plus a equals bx squared minus 1 at x equals 1. 2 plus a equals b minus 1. A minus b equals negative 3. Take your derivative. 2, a goes away. Let's just put a placekeeper plus 0 so we know we've done it. 2bx, and then we have minus 0. This is also at x equals 1, and we're now going to simplify it. We divide by the 2, and 1 equals b. So we now have our b value, and we're going to find our a value. Direct substitution. Add 1 to both sides, and a has to equal negative 2. Now the last question on this worksheet involved f of x. Two equations again. E to the negative x. We have plus 2. This is at x less than 0. We then have ax plus b, and we're looking at x greater than or equal to 0. Two criteria, continuous and smooth. For continuous, we set them equal to each other. Plug in the change in the domain. E to the negative 0 power plus 2 equals a times 0 plus b. Anything to the 0 power is going to turn out to be 1. And you'll notice we end up with 1 plus 2 equals b, for 3 equaling b. We're now going to do the smooth portion. After all, we don't know what a is yet, so we're taking our derivative. Negative e to the negative x, the 2 goes to a 0. I have a plus 0. This is at x equals 0. I get negative e to the negative 0 power equals a. That's e to the 0 times the negative 1. Notice, put the parentheses around it and follow your order of operations. It will allow you to get your answer correct. We then find our a and b. This is how we find values of a and b that make a function differentiable, the idea of being both continuous and smooth. I hope this has helped you. Please be aware we will see these eventually, but we need a little bit more practice. So this will not be on the check for understanding, but you can expect to determine whether a function is continuous would be. Please remember to come on in and get any help if you need it. I am here and available at lunch and after school on Monday, Tuesday, and Thursday, so that you can come in and get some help. Thank you very much, everybody. Please be safe, take care, and thank you. Bye-bye, all.